Hello, I'm Achyapriya Munishankar. My final project for the course Data Analysis and Construction Management, CNST 6308, is room occupancy detection. The occupancy level is a key factor for achieving building efficiency, which directly affects energy related control systems in buildings. The university buildings are useful targets for modeling occupant behavior to manage its potential of energy sources accurately in order to increase energy savings. With the advent of machine learning models and the ability for data collection whenever necessary, by sensor devices, I have gained useful insights and meaningful information for this project from the sensor data. My report analyzes such data for the purpose of occupancy detection for the smart building systems. The data set collected is from 51 rooms on the 4 floors of the University of California, Berkeley, Suthaja Dai Hall, and it was collected over a week and it's approximately 10 days in Unix epoch time. The five factors or measurements that were collected using the sensors were CO2, humidity, temperature, luminosity, and PIR motion sensor data collected over a period of 1 week for each room. The data record used for this purpose includes measurement results of the PIR motion sensor sample every 10 seconds and the remaining sensors collected over every 5 seconds in Unix epoch time. The terms such as CO2, temperature, humidity, and luminosity itself explains the function of those sensors used respectively. The uncommon terms for me were PIR sensors and Unix epoch time. The passive infrared sensor, PIR sensor, is used to detect if a human was in or out of the sensor's range. That is, it allows you to sense motion. And Unix epoch time is the number of seconds that have elapsed since January 1st, 1970, not counting leap seconds. Analysis. I have detected the percentage of occupancy of the rooms considered, and I have compared the performance using the classification models done. And finally, I have interpreted the results, and I think these will help me in ways to ponder for achieving energy efficiency. Purpose. Energy efficiency is an important topic of discussion in today's world as energy consumption is soaring up day by day. And in this developing society, we are more focused on creating comfort zone for users in commercial buildings, but not concerned about energy savings. Primarily for this purpose, the data of a university building is considered as it will have more people coming in, going in and out of the building. So the models used for this analysis are the decision tree, k nearest neighbors, and naive-Bayes classification models. Methodology. The concatenation of the data was done firstly, as the data I had was in separate Excel files for each room. To save time and energy rather than combining it manually, I used the concatenation command in Python. The data had almost 40% NaN values. Hence, records without the values were dropped. The target attributes were assigned. The 5 features discussed before were independent variables, and the dependent variables are the results showing if rooms were occupied or how much of the rooms were occupied. After cleaning, training, and testing the data set, the correlation matrix, room occupancy, and histograms of the data were plotted. Finally, the performance and the confusion matrix of all 3 models were interpreted after modeling them. Correlation matrix. It's obviously a symmetric matrix as every pair will have the same relation either way. So all the values in the matrix except the diagonal terms are nearly zero, which this means that there is no linear relationship or less linear relationship between any of the features of the data. Also, we should note that some are positively correlated and some are negatively correlated. Model performance evaluation of all the three models are here after modeling them. So comparison of the confusion matrices of all three models has shown that the true positive of all three models are higher, 0.99. But the true negative is 0.82 for the decision tree, uh, which is good. And for KNN and naive Bayes models, it is lesser, and that's not good. Also, type 2 error, that is false negative, is lower, 0.181 for the decision tree, and it's not nearer zero for the other two models, which is not a good thing. On top of all this, accuracy being 0.98 for decision tree model and 0.93 for the other two models make the decision tree the best model for this dataset. Comparison of the F1 score of each model also shows that the decision tree analyzes the data well for this dataset. So F1 score being 0.99 and 0.83 for the results in the decision tree model. Conclusion. Approximately 92% of the data shows the empty status of the room. The remaining 7% indicates occupied room, that is, which is indicated by 1. With this result, it is believed that the wastage of energy resources is almost 92% of the time. This issue needs to be addressed to save energy wastage. This graph shows the room occupancy per day for 10 days for each room in UC Berkeley building. So with this graph and the insights from the performance evaluation of the models, I pondered for ideas to increase the efficiency in the buildings. Firstly, we can make sure that heating, ventilation, and air conditioning settings in lobbies, offices, and other peripheral rooms are at minimum settings during days of less use. Based on the occupancy level of each room, one can save energy by installing automatic sensors in rooms of less usage. This way, the amount required to install them in every room is reduced and saved. Buildings can be designed or remodeled to let more natural energy in the rooms, in the particular type of rooms that would be used more. And if aesthetic lightings or other artistic energy consuming things are really necessary, they can be used where and when occupancy is high. So when at the places where occupancy is low or when the occupancy is low, we don't have to use them. References. These references were helpful for me in understanding the data and interpreting the results. Summary. The dataset and its features were described. The aim and purpose of the project were discussed, which are occupancy prediction and determining ways to increase energy efficiency, respectively. We also just in this I also discussed about the correlation between each features of the dataset, evaluation of the performance of all three models were done, and it is concluded from the performance evaluation results that there is energy wastage almost 92% of the time, and we are almost 99% sure about this, as we had 99% accuracy from decision tree model. And in this, I also pondered about the new ideas to implement for energy efficiency based on the result and performance evaluation we got. Thank you.